The objective of this demonstration is to develop a program for the implementation of bisection method. So in Google Colab, I import the libraries, import numpy as np, and I define a function. Let me pick that function from the example. Okay. So example function is x cubed plus 4x squared minus 10. So I define this function f of x, and it should return a value which is x cubed plus 4 times x squared minus 10. And then I write the keyword return and return a value. So this will remain this will return the function value. So I check it for one more time. X cubed plus 4x squared minus 10. And let's see its function calculation. So I calculate f of 1, and f of 2 just for test values. So minus 5 and 14. So very much consistent with the requirement of bisection method, that the interval a and b have function values on the opposite side of vertical axis. So I start the algorithm. I require a, which is 1, then b, which is 2. This is the solution search. I will define an epsilon value or tolerance value, say 1 e raised to the power minus 2. So just to test the algorithm, just few iterations. So in every iteration, I have to calculate a value p. P is a central value, a plus b divided by 2. And after that, I have to calculate a value of f of p, well, the function value. And then I have to see whether I have to change a at the position of p or b at the position of p. So I write with an iterative loop. So I write while I, no, not I. Well, our criteria is for epsilon. So let's define the width of interval. So width is b minus a, b minus a. Okay, that's fine. So this is the width of interval. As widths are, the interval is being halved in every iteration. So I define I value equals 0. Now the while loop, while width is less than or equal to epsilon, we have to keep on updating the interval. So I keep this calculation of p inside the circle, inside this loop. So I'm happy with the less than. When it is less than the epsilon, it means we have approached the solution. So p has been computed. Now the shift algorithm. So I define f. Sorry. Let's decide that this is first iteration. So I is equal to I plus 1 in conventional style, or Python also facilitates that you should write plus equals 1. It means I equals I plus 1, the compact structure. So I now define if f of a times f of p, the small p, if it is greater than 0. This can be greater than 0 only if both have positive signs or both have negative signs. So both are on one side of the function. So this is the time to shift the value of A, right? And else, in the other condition, B should take on the value of P. And this is the end of this if structure. And during this structure, uh, this is fine. This is complete. And finally, we will print the width of the interval. What is the width? So I write W value. Well, I didn't calculate that one. Therefore, after the if condition satisfied, I have to again calculate the width, which is B minus A, the new value of the width. So width value is there, and then the number of iterations performed. So this is the value of I. So let's see whether this simple algorithm is going to work or not. Let's see. It seems there is no red signal from the computer. Oh, width is 1 and number of iterations 0. Well, while since the only value of width was returned, which was calculated over here, it seems it didn't go inside this while loop. So width is less than epsilon. While width is less than epsilon, so width is less than epsilon. Well, it should be greater than. When width is greater than epsilon, then perform the calculation. Okay, this was the input earlier that I ignored, even though I practiced that algorithm last night. So it is also important when you test your program at the right time. So after 12, right, at the start of new day, it is not recommended to do a lot of learning stuff. It is inefficient for learning. So now let's see. Okay, 7 iterations have been performed and the width has been reduced to 0.0078. It means the algorithm has gone through the calculations. Let's reveal those calculations as well with the help of print statement. So when it is doing all that, so before getting out of the loop, I introduce a print statement. So print statement with the variables, I print the value of I. I will print the value of f of p. I will print the value of the width of the interval. And the I value is an integer. Therefore, I write the integer format percent 5d. Then for the real value of p, I use the format 10.5 with 5 decimal places and a floating number. And then for the width, I also introduce 10.5 f to 5 decimal places for the value of width. So let's run it. So the command has been accepted by Python, and you have the width of the interval. So it is very nice thing to observe that at the beginning, the interval was 1. Its width was 1. It has halved in the first iteration, 0.5, further halved in the second iteration, and it went on doing that. To make it more informative, so I write a similar kind of print statement to show the as a title. So before this one, I write the title iterations. Right. I write the okay f of p. Okay, as such, this is fine. Then this will take on the the title width. And since all these are considered as strings, so I use the string writing format, so which is S for string. So the format writing is very similar to writing formats in MATLAB or C language. So now let's see whether it has been appreciated by Python as a right syntax or there is some complaint. Nice. So in 7 iteration, it has approached this one. So once the vehicle is ready, you are now free to get to any accuracy you desire. So for 5, it's going to be a relatively straightforward process because in every iteration, the step size is reduced to 1 by 2. Right? Analogous to radioactive decay. In every half-life, you have reduction in the amount to 50%. So I hope this will improve your understanding and learning and algorithm development, and it will provide you the wings. So let's stop at this point, and thanks for your silence. So now take a deep breath. It calms the mind.